Hey guys, so now I introduce an app I've been working on for quite some time, and you will find the normative perspective and a proposal I published on LinkedIn on the GitHub repo. We're just going to talk about the app now. So please read the Euler. Um, I say please read the Euler because I didn't have the time to make the app as secure as I hoped it to be. So it's prone to get hacked and it's prone to get cross-site attacks and stuff like that because I don't hand secure tokens between the sessions and stuff. So just keep that in mind. So when you pass your token, your open AI token, um, make sure to track the costs if you don't delete it. And the best thing would be just delete it after you used my app, just to make sure that nothing happens. Or you run the app locally, that's the best, um, to try out, and then there's no danger at all. If you have any inquiries, you can always write me. I try to answer you, but I work full time, so maybe it takes a bit of time. Okay, so let's assume we are okay with the Euler, then we go to agree, and that's the user interface of the app. And so I don't want to waste too much time about all the dimensions and all the implications this app has because it's massive. You can go to like from physics to information density. You can go to simulation of social system. You can go anywhere you want to go. It's really massive. You can feed in your own tuned model here and make an awesome construction and enable others basically to use the communication you had with GPT. And yeah, it's just massive. So let's don't waste time here. Maybe I'm gonna talk about it another time. This is where the previous discussions, which are made online through the CloudRun app, I will deploy. You can see them here and reload them, and those are the physical um, models that are applied to the graph. I didn't have time to fill in those options. Maybe I do it at a later time. Okay, so here you see I have some blueprints, and let's go for now with simple inheritance. Then you see here the graph loads, and the graph moves. It moves all the time. Basically, we move toward it because um, I assume that the graph is going to be massive at some point, so it doesn't help if this canvas is too small, the canvas here of the graph, and it was a bit of a pain to get the canvas and the scale of the with graph aligned. So if there's a good UI developer out there, please go ahead, correct my app, correct my code. I'm not so good in that. So first of all, let's try to make this nicer. We say we want to have a bigger node distance. Here we see that it's still skewed the edges. So let's go for another physical model. And here we see now the skew is gone, but the nodes are gonna move away from one another, and there they stop. That's awesome. If they wouldn't stop, we just increase the damping, and then they stop moving at all. So those are the physical parameters up there. You can play around with them. I love to play around with this. It reminds me a lot of strategic games I play and like how to mark stuff. Like you can also multi-select and you can do a lot of stuff. I try to make it as like handy as possible. Okay, and now here we see basically three different graphs or connected components. And we let's just go through the base setup of one agent interaction. So here, like OpenAI agent interaction, that's a like a specific case. It's not general agent interaction, just to make that clear. So we have the user, and the user gives kind of a briefing. The following text is based on deductive problem description of a political environmental process. Don't answer normative, just translate the content to a mermaid graph. and the system acknowledges that he got the briefing, and then the user gives basically the problem space. And now here you see a specific thing. This is yeah, it already says variable, so that's a term I set hard coded basically for it to search and to replace it. So you can inherit the answer of one agent interaction to another agent interaction, and it will run recursively, meaning first it will run the lower hierarchy by the suffix here, so 1, 1 is lower, and it will run this interaction, and when the answer is given, it will populate this variable with 1, 2, which is higher, and then after it's populated, the other interaction will run, and it will be answered based on the knowledge given of the first agent interaction, basically. So this is also a massive topic where I would suggest, if you're interested in it, read up on it, because it's really cool what kind of message protocols there are and how you can play around with them. So this is just one approach of passing messages between graphs. But yeah, please go ahead, and if you have knowledge, please fork my repo and fill in those different options. Honestly, like I said, I didn't have the time, and also I'm not an expert in message passing at all, so it will take a long time till I fill out all the options. Okay, so now we have the graph, and if you may notice, it didn't load in here, so we say get JSON, and here we have the JSON, so you can simply save it for you for next time you want to use it, or whatever you want to do with it. And so this is our basic setup. And now if we trigger the agents, we expect, like I said, this to be filled and answered. Here's no variable, so this will be simply filled, this will simply be answered, and this will get the answer from the other one, like we discussed. So let's go for the trigger. Here's another thing. I really went on this topic out of a statistic perspective, because I love to do matrix analysis and play around with that. So I went quite a long way to do a simple operation, which you can see here. I saved the edges table by it, I saved the nodes table by it, and then I play around with it. So I basically make a Sudoku. I like to think of it as Sudoku on a matrix, where I have here the adjacency matrix as a first layer of the matrix, and then I populate this adjacency matrix with the content basically of the nodes. So the user input, your input, and the agent input. And then I do some kind of pattern recognition and depth first search and stuff like that. So this is why it takes so long, because I just like, yeah, it's a private project, so there was nobody to put any limitations for me on the scope. So I just went crazy or like did whatever I wanted to do. But that's the explanation why it takes so long. So basically, it saves and does operation it wouldn't normally need to do, but just out of my convenience, it does it for me to analyze my own basically dialogues with GPT. Um, yeah, so that's the background why it takes so long. So I set it to 130 seconds, so we have 2 minutes and 10 seconds, and this is quite inconvenient for the user. I'm aware of that. So there's a timer running down, so just go get a coffee or whatever. And in the background, you see, let's get here. Yeah, if you run it locally, you can see my logging habits. I love to log, like, basically this is my literature. I love to log extensively and give out all the lines that I'm interested in, and put on basically all the information I have, and also the trees and the logs. You can also go via the development console just to get a feeling. what goes on in the background, and uh when the graph data is gonna come. So yeah. Okay, here we have now the message. Let's close it down. Your graph has been saved under the name problem space can be reviewed provided MMD file represents basic simple. Okay, so I've thought a lot about like how do I put in some kind of policy layer, and my best idea was to take the responsibility from the user to name the graph, and just use the policy layer of OpenAI. Maybe you know that there's a policy layer, so if you try to ask like for some political incorrect question, yeah, there will come some restrictions. So whatever, let's don't discuss about stuff like that. But you will always get the name from the agent responses, and their random selection basically of the agent responses. So here's the answer now, and again, let's make it more convenient for us to view it. Let's yeah, it drifts apart by itself. Let's put in a bit more of it. Okay, that looks good. So I want to stop them moving apart. I increase the damping. Maybe I decrease a bit the node size again. They move together. That runs really smoothly. Heads up to the guys from WishJS. Guys, you improved my life dramatically. I love your library and everybody who maintains it. Okay, so let's just check if everything went like we hoped it to go. We have the user who got the preview. That's like a logical preview about logical argumentation, and he inherited. Oh no, he first answered the question about climate change. So let's take a look into it. And because this may be inconvenient, we just can go to edit node. And then we have here the text. Let's increase it. So this is getting very convenient to read through. And yeah, just took 1 hour of my life to make this convenient. So the problem space can be modeled as follows. Hypothesis 1, climate change is caused by human activities such as burning fossil fuels. Hypothesis 2, climate change is responsible for rising global temperature. Okay. And we go on with the hypothesis. Using deductive reasoning, we can apply various limits for a specific conclusion. Modus ponens, modus tollens, syllogism, sorry, the different kind of syllogisms. Okay, nice. So, so apparently, the agent understood it, and then let's check if the inheritance worked. So where we here. So, here we have the higher number, the higher suffix. So it's inherited to here, but before he got the prefix of the other node's answer. So basically, he modeled the answer of the other node in Mermaid. And this seems to have worked also. Let's just, hold on a second. Just have to pull it back. Let's do it that way. And let's cancel here, and let's get edit node. Let's get this text. One specific thing about the app, I set hard Control C, Control V, like copy paste. I set it hard for the graph to work, but not for text to work. So you will need to use your cursor to copy paste if you want to work with the JSON or the edit node text field, because like I said, I said it like that you can just copy paste here. I can demonstrate it later, but let's just check out of curiosity if the MMD worked. So let's call it test.mnd, and let's put it in here. Okay, damn it. Somehow my Okay, nothing to worry about. My extension went away, so let's just go for mermaid. Yeah, okay. Mermaid. Here we go. Okay, yeah, I actually wanted to not to have my previous mermaid, but I wanted to have like, okay, it just shows me my previous mermaids. I just wanted to have basically, yeah, the homepage, and let's get the live editor. Okay, let's copy paste it here. Sorry, and let's convert it, and let's see. Okay, seems to have worked also. So, cheers to the guys from OpenAI. Nice work here with GPT. Nice training data that it understands Mermaid. Okay, so that's just a simple use case. I will put in here some very elaborate use cases, extensive use cases with logical agents you can use to argue about anything. You can read the rest in the article I wrote on LinkedIn about all the motivation behind it. But yeah, I just hope you enjoy the tool as much as I do, and maybe you can come up with some extensions. Maybe you can come up with a roadmap. I really invite text as well as non-text just to indulge, and yeah, let's see where this goes. Thanks a lot for your attention, and I wish you a very good end of the year.